This video is going to look at graphing linear equations, and specifically we're going to be looking at the XY table method. So when we're looking at graphing linear equations, we're looking at equations that have two variables. So we're looking, they're going to have an X and they're going to have a Y, or in other words, they're going to have two unknowns. And then A, B, and C, when we're looking in this form here, which is classified your standard form, the A, B, and C are just representing real numbers. So those could be positive, negatives, fractions, decimals, whole numbers, it doesn't matter. And when we're looking at these linear equations are exactly how they sound. So this linear is a line, and that's exactly what it's going to make for us, is a straight line. So let's look at how do we graph these linear equations using the XY table. So you can see over here that I have my XY table. So you have a column with X's, you have a column with Y's. And when you're using this method, so sometimes you'll see problems where they give you numbers already and you kind of have to fill in the missing. But it doesn't necessarily have to be like that. So if you're asked to graph y equals negative 2x minus 4, you can pick any numbers you want to plug in for x to solve for y, and that's going to be your easiest strategy. Now, I would not make things harder for you than what they need to be, so I would pick easy numbers. I like to pick a negative and a positive, so my go-to is always negative 1, 0, and 1. So what you're going to do then is you're going to take that equation, but instead of the x, you're going to plug in your first value here, which is a negative 1. So now I go and I solve this. Negative 2 times negative 1 is 2, minus 4, and that would give you y equals negative 2. So that's what I plug in over there. You would repeat the same thing, except now you would plug in your next value, which is 0. And again, whatever values you pick is fine. You're going to end up with the same line. And then your last one is your third value, which is a 1 in our case. There, we got it. So now once you have your 3 ordered pairs, so what you have here is you have negative 1, negative 2. That's your first dot or your first ordered pair for the line, your second, and your third. So we now have 3 dots that we can add to a XY axis or a coordinate plane. Get rid of this stuff here. Okay, so what you would do then is you would just plot these 3 ordered pairs. So negative 1, negative 2 would fall right here. 0, negative 4, 1, 2, 3, 4 would fall here. And the last one is 1, negative 6. 1, 2, 3, 4, 5, 6, which would be down here. Oh, so I did something wrong, didn't I? So here, let me put that back up for a second and let me show you why I thought that. Okay, so as you can see, since I didn't do this right and I made an error, you can see that my lines don't create a straight line. They create like this curve that goes down. So that means I either didn't do my math right or I didn't plot a point right. And in my case, I didn't plot this point right. So 0, negative 4 is nothing to the right or left, down 4, 1, 2, 3, 4. So it should go right there. That is my mistake. So now you can see that when I plot these 3 points, I could get a ruler, connect, and it would make me a straight line. So I'll try to do this as straight as I can, and that would be my line. Good. All right, let's look at this next one. So I have y equals 3/4 x minus 2. And I'm going to give you a little trick. So like I said, my go-to was -1, 0, and 1. That is true, except when there's a fraction here in front of the x. Okay, so if I ended up putting in -1 here and 1 here, I would end up with fractions over here for my y values, and I don't like fractions, so I'm going to steer clear of them. So let me give you a hint as to what I can do to help eliminate the fractions when I go to do my ordered pairs. So if you notice that there's a fraction here in front of the x and you're using the XY table method, I would always use the denominator. So I would use 4, and then I would use the -4. Okay, so use a 4, use the negative of it, and then I would always use 0. So instead of using 1 and -1, instead I'm using 4s. Okay. So now when I do that, so let's plug in my first value, which is a +4. So when you do this and you do 3/4 times 4, whether you do that in the calculator or you do it in your head, you're going to end up with just a +3, which means your y value is going to yield a whole number. The same thing is going to happen when I plug in the -4, except now 3/4 times a -4 is going to give you a -3. But it's still going to give you a nice integer to plot for your ordered pairs. And then the last one, we'll plug in that 0. And 0 is nice because it's going to eliminate that fraction altogether and give you a -2. Right, so the skill of substituting in and solving is not necessarily new. The idea that we now get to pick our own numbers to put in for x and solve for y is new. That's the new concept. So again, here in this slide, the trick is if there's a fraction, whatever this denominator is, if it's a 4, use 4 and -4. If it was a 3, use 3 and -3. 5, use 5 and -5. That's the trick. It's going to get these y values to come out as positive or negative whole numbers. Okay, now that we have those ordered pairs, our last step is simply to plot them. So we got 4, 1 is the first one, so that's 4 to the right. 1, 2, 3, 4. 1 up right there. It's 4, 1. -4, -5, so that's 1, 2, 3, 4 to the left. Down 5. 1, 2, 3, 4, 5 right there. And then the last one is 0, -2, so that's nothing to the right or left. Down 2. And again, a good, nice visual self-check is that these 3 clearly make a straight line. And again, if you have a ruler or something, if you're taking your notes on paper, that would be a little easier to do. So, but you can tell that these 3 make a straight line. All right, so now we have y equals 1/2 x plus 3. So before I say it, why don't you go ahead and think, okay, if here's my linear equation, what would I plug in for my 3 numbers? So using the trick from the last slide, what I would use would be 2 and a -2, because that's the denominator, and a 0. So then what you get here, plugging in that 2, 1/2 times 2 is 1, which gives you y equals 4. That's the first. The second one, plug in a -2, and that's going to give you 1/2 times -2 is a -1, and that'll give you y equals a +2. And then the last one, you plug in 0, and that gives you y equals 3. Okay. All right, and now let's graph it. Sorry, this is hard to erase. Okay, so we got 2 4s, so that's 2, 1, 2, 3, 4s up here. Then we have -2, 2, so that's -2 to the left up to here. And then we have 0, 3, which is right up there. And again, nice line. There you go. All right, so go ahead and pause it and try it. And if you want, you can pause it and try to fill in the XY table and then hit play. Watch me do it, see if we match, and then you can hit pause again to graph, or you can just go and try all of it together and then hit play when you're ready. All right, so because my denominator is 3, I'm going to do 3, -3, and 0. So that gives you -1/3 times a +3, which that's going to yield you a -1. So that's y equals -5 would be the first one here. The second one, that would give you a +1, which would yield you a -3. All right, and the last one, would give you a -4. So that's what you should have got for your XY table. 3, -5, -3, 3, and 0, -4. Now, if you didn't use 3, -3, and 0, you could have got different values. So it's kind of hard to check because here's what I got. But if you go listen on and watch me graph it, or if you've attempted to graph it, then my line should be the same as your line, which means my points should fall on your line, your points should fall on my line. All right, so let's move on to graphing it here. All right, so the first one we got is 3, -5, so that's here, 1, 2, 3, 4, 5, that's down here. 3, -5. -3, -3 is -3, -3 is here. And then 0, -4, right there. Good. Okay, so that would be my line. Off there. So again, if you didn't use the points, these x values that I used, that's okay, but so your point should fall on my line. Okay, so if you got probably if you used 1, you would have gotten 1, 2, 3, 4, -4¼ ish. So it should fall here. So you should be able to use your points and say, okay, if I go here and down, this point is also on that line. That sort of thing. Or you could check my points. Do my 3 points fall on your line? All right, now let's look at horizontal and vertical lines here for a second. So if I have a linear equation that looks like this, y equals 3. Well, this is saying that my y value can only equal 3. So I have no choice but to make this whole column of y's 3. But what does that mean for your x's? Well, exactly what it meant before. I can pick any number I want to and put in here, because it doesn't matter what this is. This equation is telling me what those have to be. So when I look at something like that, so I fill in all my 3's, pick any numbers you want for x's. When I graph them, you're going to end up with -1, 3, which is right here, 0, 3, which is right here, 1, 3, which is right here. So what you notice is it wouldn't matter what you picked for that x, because this is spanning this whole entire length of this x, your y value is always going to be 3. So whenever I have y equals any number, that's going to give you a horizontal line. Okay, so y equals 3. I have no choice but to put 3's. It does not matter what your x is going to be. You're always going to get a horizontal line. Okay. Your second is x equals -2. So now I have x equals a number. So that means I have to put -2's in for my x because I don't have a choice. That's exactly what that says. And I could pick anything I wanted to for my y's. And when I go to do that, -2, -1 is here, -2, 0, -2, 1. So notice that that x will always be -2. So if I have x equals any number, it doesn't matter what it is, fraction, decimal, doesn't matter, you're always going to get a vertical line. Right? And we will continue talking about horizontal and vertical lines in future videos.